Hey guys, welcome back to this week's Friday Focus. So this week's Friday Focus, we're going to talk about when to use and not use expanded octets. So looking at your labs, one of the things I noticed was we were expanding octets when we didn't need to or we didn't have to. So expanded octets, remember, are the central atom can take on more than 8 electrons if it needs to. So that's the first thing. And then also if it's in the third energy level or a higher energy level. So what this video is going to touch on is when do we expand octets and when do we not. I'm going to kind of fly through some Lewis structures. You guys did a really nice job on the lab, so I'm going to assume that you know how to do Lewis structures. In this video, we're just going to hone in on, do I expand it? Do I not expand it? So in our first example here, it's going to be a pretty obvious one. So phosphorus is likely going to be our central atom, and then fluorine is going to be the atom that's terminal or around that phosphorus. So right away I see 5 fluorine atoms, probably going to be an expanded octet, right? So if it's got 5 things attached to the central atom, we're going to probably have to expand the octet, and we do in this one. So very quickly we would do phosphorus has 5 valence electrons, fluorine has 7, and then we have 5 there. So 35 plus 5 is 40 valence electrons. Then we would put phosphorus in the middle, and we would attach our 5 fluorine. And then distribute lone pairs. So we've got 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, and 40. So I distributed all of the electrons. Everybody's octet is full. Phosphorus hasn't expanded, but that's okay. He's in the third energy level. All right, so let's take a look at the next one. So this one isn't as intuitive, whether we need to expand it or not. So let's dive into the Lewis structure and see what we can find. So we've got sulfur. Sulfur has 6 valence electrons. Oxygen also has 6 valence, and there's 4 of them. And then we also need to take into account that this is a charged particle. So that's a 2 extra. So we add all these together. We got 6 plus 24 plus 2, so 32 valence. All right, so we draw the skeletal structure. Sulfur with the 4 oxygens. I always start with single bonds. So we got 2, 4, 6, 8. And then distribute the rest. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32. So in this example, I've distributed all 32 electrons. Everybody has a full octet. This is the Lewis structure for this. Now, this was the one in the lab that I think was the most missed. Can this be drawn with double bonds? It can. So we can expand sulfur's octet by taking, maybe these electrons, throwing them into a double bond. So there are still 32 electrons on the paper. Sulfur now is touching 10 instead of 8. Sulfur is in the third energy level, but we don't need it, right? We were able to write this Lewis structure with only single bonds, and that's what we're going to do. So this one would not need an expanded octet. Sulfur is happy with just 8 electrons. He's fine, okay? So this would be an example of, nope, don't expand the octet. So let's take a look at this one. Again, not intuitive. We've got 2 chlorines, 1 sulfur. So sulfur has 6 valence. Chlorine has 7. There's 2 of them. So 14 plus 6, that's 20 valence. So sulfur, chlorine, and chlorine. We start with single bonds, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So again, this is another example of I was able to write this Lewis structure with just single bonds. So again, sulfur is technically in the 3rd energy level. We could expand his octet, but there's absolutely no need to, right? We can write this Lewis structure with single bonds. Everybody's fulfilled and happy. So that's just kind of some examples that I saw coming out of the lab. I'm not sure why we chose to expand some of the octets. I don't know if we were misled by Google or if we were just love some double bonds. I'm not sure what happened. But we only expand octets if we absolutely have to. How do we know that we have to? If we've got too many valence electrons and we need to find a home for them. If we've got 1 central atom and 5 different atoms or 6 different atoms around it, that's when we expand the octet. But if we can find a way to write it without expanding, that's going to be a more stable molecule. I hope you guys found this helpful.